and welcome to the Cisco support community. Today, we present another exciting Hangout on Air. During our event today, our speaker will introduce iOS XR and its command line operation. My name is Qiming Huang, and I'm the product manager for Cisco support community here at Cisco. Our expert joining me today is Vivek Rahil, a network consulting engineer at Cisco, who is also a Cisco certified Internetwork expert. Hello, Vivek. Welcome to the Hangout.
Hello, everyone.
Now, I would like to briefly outline the format for today's Hangout on Air. Vivek will start with a short presentation on iOS XR and its command line operation for the first 30 minutes, followed by a live demo for 50 minutes. Afterwards, we'll dive into the question and answer sessions for the remainder of the event. During our live session and demo, you may submit your questions on Google Hangout event page. So please start posting your questions now to give it the best chance of being answered by our expert. Let's get started. Now, I would like to hand it over to Vivek, who will provide insight on iOS XR. Go ahead, Vivek.
Welcome, everyone. Today we will discuss about iOS XR, how it is coming out into the market. So let's just get started without wasting any time. Just a brief history. This started in 1997 and was named as iOS NG. Officially, it was released on CRS1 routers, the core in the service provider, in 2004. Then thereon, it went on to be released on the GSR as well as the ASR 9K. And apparently, these are the only three routers that currently support iOS XR, and these are all routers that are there in large enterprises or service providers. Going more deep into the iOS XR, so like any iOS, the iOS XR also has command modes. The first being a normal operations, an executive mode, if you will. You can run basic show commands there, just like we used to do in the iOS. Then there is a configuration mode wherein you can dive into the router and configure every bit of protocol or technology you wish to run. Then there is the admin chassis operation. So now, if you're familiar with iOS, this is one of the differences you would see here. There is an admin mode as well inside the iOS XR command line. So you can go into the admin mode, wherein primarily there are two functions. One, you can look at what are the PI files or let's say various iOS, various software images installed on the router. Then you have the config mode, wherein if you log in, you would be able to install new SMUs, which are software management units. And if you look at this slide, it also says, for example, the normal operations mode is also called as an SDR executive mode. So exec mode. So SDR is basically your secure domain router. We'll briefly discuss about it later. Let's get into the configuration key concepts that we have for iOS XR. So iOS XR basically has a phenomena called as a two-stage commit. Then you have a config history database that the iOS XR maintains for every router. Rollback, atomic versus best effort, we'll see what these are. And what happens when there are multiple users logged into the router. So first, let's look at the two-stage commit. Basically, two-stage commit, you would see that if you look on the left side of the presentation, there's a network administrator who's entering some changes into the router. So the first stage comes here when you're entering these changes, right? So these changes, whenever you're typing a command or anything into the router, a syntax check happens on the router. And then when you're saving that configuration, right? So that time also, the configuration is checked against what is available on the router. And only after successful passing, it takes effect. So this is how it works, right? So first, there's a syntax check after each line. So for instance, if you just typed IP address instead of IPv4 address, the router would not take the command and you will be given an error. That's the first stage of commit. The second stage is when you're actually wanting to put the target configuration into the active running configuration for the iOS XR. You would just do a commit. So for example, for in iOS XR, you have commit as a command, which is replacing save. And unless you do commit, the configurations do not take effect on the iOS XR. So once you're doing that commit, there's a semantic check that runs on the router, and only if the semantic check is passed, the configuration is there in the show running. So, okay, so what do we mean by semantic check? Looking at the screen, if you say router OSPF 100, you've already got these interfaces under the areas, and let's say there's another interface that you need to add. You need to add some attributes into a particular interface, and by mistake, rather than calling the interface gig 0/3/0/0 under area 0, you call it under area 1. So once you're doing the commit, it will send you an error. The router will send you an error, and that's the semantic check that happens. So this is basically the two-stage commit that came out with iOS XR, which was not available with iOS or any other platforms, because as soon as you write a command, it just goes into the running configuration for the router. Okay, next is the commit history. So in iOS, there's no such thing as what was written to the show run earlier, whereas in iOS XR, Cisco has provided the benefit, I would call it, of keeping a history of all the changes that were done in the router previously. So once you're doing it, you can always have a look at these changes that were done earlier. So for example, the configuration that our network admin just administered in the last two slides, once that configuration has been committed and it is presented in the show run, you would see there's a new label that gets added, which states that this is the committed history for the configuration changes that we did, and a unique ID is also generated for that particular configuration change, whatever we did. Okay, so now why did we do this, right? So it gives you an added benefit. For example, let's say you had configured a lot of lines in the configuration, right? Not just these 4 lines that are guided. And you have to roll back for some reason. Maybe the change was not successful, or maybe the guys called up the change. So in iOS, you'll have to practically type each and every command again with a no command in front of it. Whereas in iOS XR, you could simply go into the config mode and you can ask the XR to load the rollback changes. Now, you can either put the commit ID there, let's say number 2, or while committing, you can always give the configuration a name that has been committed there. So what happens is, as soon as you do this, put this command in there, load rollback changes, and the change ID or the change name, the router automatically creates a rollback configuration, and that is committed to the show run. So if you see, the router is maintaining a commit history and a rollback as well. Now once you have done this rollback, now that rollback configuration also gets added as a number in the commit history. It's also assigned a unique ID, and it is always there present in the network. So let's say tomorrow you have the change window again, all you have to do is again load rollback changes and the commit ID, and you're done. You're good to go. Okay, now for rollback, there are various methods that can be implemented. So either in the last slide we saw that you can load back a particular change. Now what you can do is you can also ask the router to roll back any changes that were done up till a particular change. So for example, you had configured a change on Monday, then you had a window on Tuesday and Wednesday and Thursday. Finally, there is some issue and you're not able to figure out which change was it exactly. So you roll back the router's configuration to a point where you know that this was working fine. So you give this command load rollback changes to, which tells you that, okay, I have to go to this commit ID, and then you put the commit ID. Then again, once this is done, a new commit history will be created, a new configuration will be there in the rollback. You also have the option specifying last to number, so you don't have to basically go out and figure out what was the change ID that was created for the particular change. All you have to do is you just say last two. So the last two changes that were there committed into the commit history part of the router's process will be rolled back, and again a new commit history will be created, denoted by number 5 in the presentation. Okay, now that was the rollback. Now you want to do a commit, right? So you can always have, again, last two, you commit the changes, and again a new commit ID is created in the commit history. Now, okay, so we all know that on the iOS XR, if you have to configure something and you want to save it, once you are in the configuration mode itself, you will have to put the command commit so that the router, so that the configuration takes effect and it is presented in the show running config for the router. We will see this in the demo section as well, that once if you do not do that, router will ask you, because you cannot exit it without saying a yes or a no. So now we commit, right? So there are two commit behaviors that are there. One is the commit atomic, that we call it, which will be always the default behavior, which basically it means is all or nothing. So right, that we have a two-stage commit. So once the syntax passes, now there's a semantic check happening, and now you see that the semantic check does not pass because, for example, in our slide it shows that the BGP cannot be a task group name, right? Just for example. So now what happens is the router will stop, and any changes you were trying to do would not be present or would not be done. So for example, the administrator here was trying to configure a gig interface along with a task group named BGP. Since that failed, so all of it went off. Now this is the default behavior that iOS XRs respond to. There's another method which is best effort, and as the name suggests, that you commit whatever is right, and for whichever lines the syntax semantic check fails, do not commit that part. Right? And now this is not there as the default option. So all the iOS XRs that they run on atomic commit option. After this, okay, the best question that anybody asks is, what happens if I have, so for example in iOS routers, right? So there are two network administrators carrying out their respective changes. So whatever you are typing is going into the show run, as well as whatever the other person is typing is going into the show run. So multiple times this results in inconsistent configurations because you guys are doing something or the other, and it is quite possible that person A could affect person B's configuration changes. So Cisco has added this behavior of multiple commits. So per se, we've got two network administrators there. They're trying to put their configuration changes here. So whichever admin does the first commit, that goes through the normal commit process. So the two-stage commit comes there, and he goes right into the show run for the router. Now the second admin was typing at the same time, but he does a commit at this later or second to the first one. Now the router is intelligent enough to figure out that, okay, both configurations are going at the same time, but now the commit has again come up. So the router would ask the network admin that, since while you were doing this commit, there is another commit that has happened. What do you want to do? And would you like to overwrite, or would you like to proceed with your commit? Now the default option is no, right? Because you never know which what was the configuration done by the other person. So you might want to check that. Now, okay, so this is the normal stage of it. Now there can be a reason. There can be there can be a reason you've got a layer 2 admin and you've got a layer 3 admin, and the layer 2 admin is performing his normal change. But at the same time, there's an outage in the network, and the layer 3 admin now has to configure something. Now, just to be sure that he doesn't have to go through this multiple commits process, what he can do is he could enter the configuration mode using config exclusive command, which should block any other user from attempting to commit the changes. Now, that's all about the commit part of it that we have. And the best part, which I absolutely like about iOS XR, is the way you can do the configuration blocks, right? You can view the configuration blocks. So, for example, in BGP, I mean in iOS, if you wanted to check the BGP configuration, either you do a show run and a whole lot of configuration comes out, or you do an include, or you do a pipe begin, or you do a pipe section. Now in iOS XR, this is there by default. So what it happens is show run router BGP or show run router OSPF. Only that particular block of configuration that comes under this part is displayed, and all the other configuration is not displayed. So this is the best part about iOS XR. One of the best parts, I would say, because there are many best parts, which you can always refer to for checking your configurations. Okay, the next topic is command authorization. In iOS, it was pretty simple. Either you put a local username password there and give the user a privileged mode, or you use attacks. In iOS XR, it's task-based. So you've got tasks there. We'll discuss about all of this. You've got task groups, you've got user groups, and you've got on-box or Takax or radius authorization. So now the tasks, they're the building blocks for on-box authorization scheme. Now when I say on-box, it means local authorization that happens within the box. Okay, so for any task, you would need permissions. There are 4 types of permissions per task: read, write, execute, and debug. And these are the various tasks, example of various tasks that you can perform in a iOS XR. So for example, BGP is a task. AAA is a task. ACLs are a task, right? Now, okay, so now one of the examples, right? So you now in a particular environment, you would always want that some users have a certain level of access while others have a different level of access. So that is why you've got those tasks, right? Read, write, execute, and debug. Now you create different user groups based on the task that is required. So here, for example, what we did was we've created a task group called basic admin. Now this basic admin person can only read certain features, write, and only debug. He can only debug BGP. This is how you would define the various tasks that the admin would be able to do. Now you would then have to create user groups for every other admin that would like to log into the box. So you've got a user group NOC staff who's got the task group operator that was also created, and task group basic admin. Right? These 2 task groups are there, and at the same time, it can inherit task groups from any other user group that has been created. So, and the other one was the all users, which basically has task group basic stuff. So primarily what we tried to do was in order to reduce the configuration lines, you always have to create a task group for the L1 admin. Then you have to create another task for the L2 admin, right? These will be different. Now L3 would always have these 2 task groups for himself, in addition to some other higher level configuration commands or debug commands. So you don't have to call each and every task in for the L3 user as well. You can just inherit those task groups from L1 and L2 user profiles and just add on the other task groups that you want. Now, very valid question. Which tasks are required? How do I know that for doing this particular command, what task do I have to use? So the IOSXR gives you an option that wherever you are, whether you are in the exec mode or the command mode, and you want to do a particular kind of configuration, for example, you want to configure out a BGP, if you put the keyword describe before any command line that you have to do, it would give you the task IDs that you need to be present for that particular user to perform this configuration. Now, obviously, you would log into the router with your own username and password, and you will be able to type this command out, and it will give you the task IDs that are required for you to access this. Now, on-box versus off-box authorization. On-box, I said, is a local authorization. Off-box is with radius or TACAX. And you can always configure per command authorization with radius or TACAX server. Now, this IOSXR is a role-based access. So, if you're configuring your AAA server, you'll have to select the profile for a role-based access, and then you will be able to log on to the box. One thing that I learned about the off-box authorization or the authentication with TACAX or radius is that whatever user group or task group you are preparing or you are creating in the radius has to be present on the IOSXR box for you to be able to log in, because what happens is that the AAA server will send these details of the user group and task group to the particular chassis, to the particular box, and then it will be matched with the user groups and task group present on the router, and then only you will be allowed access to the router. Access lists. Okay, so now in IOSXR, there are no such thing as numbered access lists. All are named. You can type numbers though, but they will be treated as text only. Now, almost iOS also have that you get to have sequence number, so you can easily manage your access list. So, for example, you wanted to put something between 10 and 20, you could always do that. You can always call the sequence number and insert the line inside, and that's what is also available on the IOSXR. Now, notice in this the command is IPv4 access list, and then you type the name. So why IPv4? Because IOSXR is coming now, wherein the world is transitioning towards IPv6. So there is no unified keyword as IP. It's either IPv4 or IPv6. So whatever you do on the IOSXR, it will always, if it has to do with IP, you'll have to specify the keyword IPv4 or IPv6. It cannot just be IP and access list like we used to do in iOS. So a little bit of changes there, but it's simpler, believe me. Once you start working on IOSXR, you'll love IOSXR. Now, management interfaces. In XR, there's an added security. So the user will have to specify that this is the particular interface that I want to use for providing any access. So what I have to do is I'll have to say that this is the particular interface and whether I have to allow or block. So this is a pretty crude example where I've said interface all, but in most of the service providers, what we want is we want only the management interface to work on the management part. To be able to access the router. So you say interface and the management interface that you've chosen to access the router. And this is an added level of authorization or security that is there for the router. Packages. Now that's the heart of IOSXR. Okay. Now in iOS, there's just one software. You load that software on the router and your router is ready to go. IOSXR is a bundle of software. This is the best part about IOSXR. Also one of the best part about IOSXR, because what you do is you've got a package for routing, you've got a package for forwarding, you've got different packages for every other component in the router. So supposing in future one of the package goes corrupt, So the routing goes corrupt, but your forwarding package is still there. So it keeps working as if nothing has happened. PI, how do you install these packages? That is what PI is, package installation envelope. This is used to deliver any of the packages. Major releases, you would have new functionalities there. You have maintenance releases, which are software fixes, and you have got smooths, which is fix for a specific bug, software maintenance unit. So, and you can always install these either from the admin mode or the SDR exec mode. Installation concept very simple. It can only be done once the system is operational. They can be added or upgraded. System will perform a sanity check. As I said, only from SDR exec mode or the admin mode it will be done. 3-phase install, we'll see that in the next slides. First, you have to copy the image to the disk. So you go install add and give the full path. So that is added. The whole list of operations come out here. Then you have to activate the PI that you just downloaded. So install activated, give this name of the location where it is and the file name. Once that is done, you'll have to commit the particular install, and only then it will be there in the router. Now, some of the PI files would need a reload of the router, some don't. It's listed there on the Cisco website which one need a reload. Deactivating, again simple. You just have to put install deactivate, but remember it's just that the feature is no longer available, but it is still installed and it can be reactivated anytime you want. You can always look at the installation. Now you can go to the display installation entries. You can always, show install log. You will see the logs. Then you can pick particular request ID. It will give you the exact details about the whole whole install process that had happened. Let's quickly have a look at the routing, and then we'll go over to the demo mode of it. Pretty basic. If you look at the slide, you can see that every configuration that is done for OSPF, right, is all under router OSPF. So people familiar with iOS can easily make out the difference, because in iOS you configure the router OSPF in the global configuration mode, and any specific, for example, if you want to specify a cost, which we are doing here in area 1, interface gig 0302 is done under the interface in iOS, whereas in iOS XR, every configuration basic happens under the router OSPF process command or mode. This is a sample configuration that I've prepared. So you've got OSPF v3 and OSPF. You have to call the interfaces inside the area. This is the hierarchy that will have to be followed. Some of the show commands that are there, show OSPF neighbor, OSPF neighbor detail. If you notice, in iOS it had to be show IP OSPF neighbor, whereas in iOS XR, like I said, there's no such thing as IP, it's either IPv4 or IPv6. So if you don't put anything here, so it is show OSPF neighbor, it will give you the OSPF process. If you have to look at OSPF v3, you do show OSPF v3 neighbor. So pretty much the same commands there in as well as that are there in iOS, just the IP keyword is not there. All the other commands remain the same. Database router. Now, if you look at the ISIS, so the configuration basics for routing remains the same. So for ISIS, you would see that you just enable the ISIS in the global mode and assign interfaces to router ISIS. Sample configuration, under router ISIS, you would perform the net command, and in interfaces, you would call different address families that you want the ISIS running for. Show command, show ISIS neighbor, these are exactly similar to that which are there in iOS. Same commands. You can look at the routing table for ISIS IPv4 topology, EIGRP. You can look at the EIGRP configuration, which is again done here. Just since EIGRP does not have concepts of any areas, you call it under an address family. So there are multiple interfaces that are called under the address family. And then again, everything is done under this. One of the sample configurations for router EIGRP, which is present on the screen. show commands, instead of show IP neighbor as in iOS, you omit the keyword IP and you get all the IOS XR commands there. All the same, it gives you the exact information that you would get in a particular iOS router. Static routes, again the command syntax is changed. You would have to enter the router static mode, mention the address family that you want to configure the static route for, and configure just the static route with the slash notation. There's no mask here. BGP, it's again a key concept for iOS XR. This I think we will see in the demo session as well. So you've got the basic funda is for any address family, you will have to initialize address family first under the global configuration. Once that is done, then only you can go into the neighbor mode and initialize or call that particular address family. These are the address families that are present for both multicast as well as unicast, IPv4 and IPv6. So in order to configure BGP, you would assign a BGP AS number, normally done. Initialize the address family. This is important. You have to initialize the address family first under the router BGP, create a neighbor, you assign a remote AS, and then again you have to call the address family, and there are address family specific commands that you'll have to, that can only be entered under the address family. These are some of the show commands that you can use. Show BGP process gives you detail about the process that is running on the router. Show BGP IP for unicast summary or show BGP summary gives you the same output. VPN v4. So you have to call the particular address family and the BGP once you want to check that particular information. VRF can also be there. Neighbors configuration, you put the IP, you get the configuration that you did for that particular neighbor. BGP policy will show you what was the policy applied. Now another key concept, which is RPL. Now RPL, it's a big picture there, right? So it's basically a routing programming language that is introduced into iOS XR, and it pretty much replaces route maps, and prefix list, everything, etc. are also there. But RPL is the next big thing. It's all about scripting that you do here, right? Few CLI lines, we'll see how. So there are various actions that you can do in RPL. You can have an action as pass, which would basically grant a ticket to allow. Then you can set values like you used to do in route map, right? So set local preference and stuff like that, set next hop. So that same set command is here, and drop if you want to drop something. So there's no such thing as a permit statement or a deny statement in route policy. It's just one policy, and then you define the actions. We'll just see the sample configuration here. So for example, here you call a route policy, any name there, you give any name there, and then you set something. For example, we are setting weight here, then you can set med here. And there's also a concept of nested RPL. So there's a route policy 3 in which you call another policy, and you can also add certain other commands. So basically what we're trying to show here is it's flexible enough for you to do practically anything with the RPL that you would normally do with a if-then-else statement in any programming language. So that's been inserted into iOS XR. Along with RPL, you get prefix set, which you can call into RPL. So you can do match prefix set. This is how prefix set works. It's all about the slash notations. There's no configuring the subnet mask here. AS path set is used to match the BGP AS path that we used to do there. So that was the AS path only, and now it is the AS path set. This is how a sample configuration there. Community set is also there, which is used for matching BGP community, and you would also see an extended community set, which is for matching the extended community, so which you would use in an MPLS VPN environment. There's an RD set. You can also match the various RDs you want to take action on. Now using RPL, like I said, RPL you can you can practically configure or have an action that you will in the IOS XR, and then you have to attach them to various locations where you want these RPLs to take action. So for example, you can have them in the neighbor policy, deny specific routes or not, change their attributes. There are other, we'll just show you the BGP attach point that is there. So that's how you call a route policy. It is always called inside an address family, be it IPv4 address family, VPN-v4, IPv6, any address family. You would call a route policy within the address family. This is the show command to see the route policy. You can see the show RPL route policy. If you only enter show RPL route policy, it will show you all the route policies that are there in the router. If you give the name, it will give you the exact information about the name. A little bit about MPLS before we jump onto the demo. So basic configuration, again, everything is done inside the MPLS LDP mode. There's no configuration that you do on the interfaces per se. Monitoring, it's the same neighbor, because in iOS also you would do a show MPLS LDP neighbor. Bindings, you would see show MPLS LDP bindings. It would practically show you whatever bindings are there from whichever neighbor for any prefixes. And these are the other options that you get for show MPLS LDP. Let me just quickly now change over to the demo session that I had prepared for you guys. Okay, so I've got practically two routers here, R1 and R2. They are both connected directly with each other. So this is how I've configured them. So you see, right, show IPv4 interface brief is what you'll have to give into the iOS XR. I've configured a loopback, and I've configured a gigabit 0/0/0/0 interface with the IP address on R1 and with another IP address on R2. Let me just increase the size here so that it is easily visible. Now what we're going to do here is I'm going to show you how exactly we will configure OSPF between these two, how we can monitor that, and then run MPLS on top of it. Let's get cracking then. You get into the configuration mode. Now, like I said, right, everything goes into the configuration, the particular protocol's configuration mode. So we want to do OSPF, SSID. Now, OSPF has the concept of areas. So you would go into a particular area that you want to run on a particular interface. Here you would call an interface, and let's see, we call both the interfaces in here. So now what do? We're done? No, wrong, right? So if I exit out of it, I can exit all the way, but now when I try exit, it will not let me do that. It will give you an error. Uncommitted changes found, commit them before exiting. So you've got three options, which is these. If you cancel, you can again get in the exit mode. You exit, it'll again give you. So unless you say a yes or a no, these changes will not take effect, and you will not be able to. It will come out of the configuration mode. So let's configure the same on R2 here. Out of OSPF 100, area 0, interface loopback 0 is what we will have to advertise. Want to run OSPF. Type it there. Most common mistake with almost all Cisco engineers. And now we commit this here. Right. So now I have OSPF running between these two. If I want, I do show OSPF neighbor. It's coming up. So if you notice something, I did not do show IP OSPF neighbor like we used to do in iOS, because it's not there. It's only show OS. Now you have the protocol still, because it goes on to the default timer, so they're still negotiating with each other. they should come up now. And yeah, so now you have the state as full, and one is being selected as a DR and the other as BDR because we're running it on the LAN interfaces. We will do some of the things next, but let's first try and see how we configure LDP. So you'll have to get into the MPLS LDP mode, and basically you just have to enable the particular interface that you want to run LDP on, and you commit those changes. Similarly, we do on R2. So I was also showing you about the task groups and stuff, right? So I can do this, describe MPLS LDP. You see this gives you a lot of information, right? And this is how in this particular parser it is defined. And to enter the command mode, you're doing LDP. Let's check. Show MPLS LDP neighbor. This will show you that I have a neighbor already configured. So let's see my IP address on R2 2222. So this is OSPF in action. I can ping that particular node. Now if I have to try MPLS, it's the same command, ping MPLS IPv4, and you give the whole subnet. Yes, this is exactly what I wanted to show you. In IOS XR, by default, you will not be able to ping on MPLS because you have to enable MPLS OA, which was not there in iOS, because in iOS you don't have to enable MPLS OAM or any other commands in order for the ping to work. And see the beauty of iOS XR, it is giving you to enable use MPLS OAM global config command. Now if I try and run this particular command, which is a ping MPLS, this goes through. So key difference here between MPLS in iOS and iOS XR is you will have to enable OAM, and the key difference for configurations between iOS and iOS XR is everything within iOS XR goes into the router command mode. It does not stay on nothing goes into the interface. That is basically what I want to say. And now in the interest of time, I think it's about time that I took all for giving you the presentation and the demo mode. It's now question and answer mode. So if you guys have any question, just post them and I will answer these. Let me just post this here. So one of the questions that I saw on the event page was, what is RPL? So I think we've covered that. That is the routing programming language, which is basically replacing route maps in the iOS XR. And with this, you can practically do anything that you would do with the if-then-else statement, if you know what I'm talking about. Second question, one of the questions that I saw was you wanted a book that would give you details about the various configurations that can be done. Well, you can always look at the video that I just did, but joking, just kidding there. There's a book called Fundamentals of iOS XR. It's available there on Cisco Press. You can go and have a look at this. It's, I think, Concepts of iOS XR Fundamental. It is being written by 4 CCIs that are working within Cisco. There you will be able to see, and that book is available on Cisco Press. It's a comprehensive guide of everything that you can do on Cisco iOS XR. Let's look at other questions. Do I need separate licenses for running individual packages? Yes. Uh, there are licenses required. So, for example, the basic ones, when you get the iOS XR, you would have the basic routing component and forwarding component, line card components, etc. will be there. But let's say now you want to add another line card which is optical. So you need a license for that. Those licenses. So basically, for any advanced software package that you want to put on iOS XR, it's all licensed. You'll have to purchase a license for the same. Another question that I can see is benefits of iOS XR. Well, somebody did post there that it's redundant in software, but the other basic or the main benefit of iOS XR is every component that you run on the platform is independent of each other. So you've got a component for OSPF and you've got a component for BGP. Supposedly tomorrow there's a failure in the OSPF process. That process crashes. Your BGP process will not be impacted. Any other process will not be impacted. And now you've opened a case with tag and you see that, okay, this was the particular bug that was hitting, just plain luck. So now you have to upgrade the package. Now in iOS XR, you just have to upgrade the package. You do not have to reload the entire operating system. Whereas in iOS, it would mean you have to load the entire operating system and there's a downtime associated with that. Whereas in iOS XR, you just have to upgrade that particular, not rather upgrade, you just have to add another PI file for it or a SMU for it, which would take care of the bug. Now, some SMUs are rebooting in nature, some are don't. That is how it works. Okay, another question, iOS XR different from NXOS? Okay, so NXOS we all know is the Nexus operating system that is there running on the Nexus devices. That has a different application to it. You enable the features there that you want to run, right? And they're already there. NXOS also does not have different packages or SMU, so if there's a bug, you've got to upgrade it. Whereas iOS XR brings that benefit. But I'm not trying to say that iOS XR is better. iOS XR is different and is present only on 3 other platforms. Where on 3 platforms, which is the CRS1 and the CRS1, the GSR and the ASR9K. Everything else pretty much runs on iOS. I would say 80% of products runs on iOS. Then you've got NXOS for Nexus. That should answer that question. Okay, so iOS XR are going to be available on routers. I just answered that. It's only available on 3 for now. We don't know how future it will work, but I think probably iOS XR will be there for basic high-end routers. It will not be present on normal home routers. iOS XR simulator be available on public. Okay, so yes, there is a plan. I don't have the details, but for now, the iOS XR simulator is available for partners. For end customers, there is a plan. It should come out somewhere in the next year, but yes, it is planned. Otherwise, if you want to get a hands-on, you can always book a rack and get your hands-on done there. Okay, I think I've taken care of all the questions that are coming up. Okay, there's somebody said they wanted an explanation about the secure domain router. So if you have worked with firewalls, right? So secure domain routers are basically kind of a context that run on the XR routers, and they would give you different admin rights and different primarily different contexts that. So it would be like multiple virtual routers running on the single platform. That is what a secure domain routing is. Let's see. Okay. All right. There's one other question which is about what is SMOO, right? So SMOO is soft. You hit a bug, and now you want to upgrade that particular, you want to correct that bug. So for that, all you have to do is uh, there's a SMOO that will be available on the CCO websites. Yes, the SMOOs all are available on the CCO website. So when you go to download an iOS, if you select iOS XR there, you would get an option of SMOO available on the CCO website itself. You can, and they are for convenience, they are listed there with the bug ID, so anybody can easily look at the bug ID and figure out, okay, this is the SMOO that I want to upgrade or update on my router, and you can easily update that. A document that talks about CLI differences between iOS and iOS XR. Okay, I am not aware of any such document, but I am pretty sure that the fundamental book that is there would give you a brief detail. From my side, if I wanted to add a brief detail, just remember any protocol configuration. I mean any, right? Be it OSPF, be it MPLS, be it traffic engineering, anything happens under that particular protocol configuration mode. You call the interfaces in the protocol configuration mode rather than, as compared to iOS, you go into the interface and do that. So the basic difference being, in iOS, under interfaces you would see a lot of configuration, whereas in iOS XR under interfaces you would only see an IP address. If you're running layer 3 VPNs, then a VRF or a MTU configured, nothing else under the interfaces. Just 1 second, let me look at the questions. Okay, from where we can get information about the features covered in particular license. It actually works on the other way around, right? So you choose the features and then you get licenses for them. So you can go to cisco.com/go/IOSXR. This licensing information is available on that particular website. Okay, any more questions? Okay, I am getting one question. It says, what is the reload time for iOS XR routers in the CCI SP lab? Well, frankly, friend, you never reload any router in a CCI lab. But if you do, I've looked at the blueprints. It's a GSR, so practically you can say 15 to 20 minutes will be there. Okay, another question. When will be a presentation on IPv6? We can schedule something out. Stay tuned to the event pages on the Google Hangout, and you will hear from us soon. Okay, any other question? Does MTU less than 1500 affect browsing? Okay, so this is not something related to the iOS XR. There are certain sites that require a higher MTU value. For example, we all know about Yahoo. It needs higher than 1470. If you have lower than that, it always breaks down. And there are certain sites which do work with even lower MTU sizes. So I would say yes and no to that. Okay. Any more questions? We've got some time left here. Partner link for iOS XR. Okay, I will post that link on the event page itself. Just check this in the next 24 to 48 hours, and you'll have that link for iOS XR simulation on the event page. I'll do that. Okay. Chiming, if there are no other questions, we can probably wrap up.
There is just one more question submitted in.
TCL scripting available on XR. No, it was an iOS feature. Yeah, okay. Okay, the question is TCL scripting available on XR. Well, as far as I've worked on, I never had to do any scripting on the XR per se, but like in iOS, it doesn't have TCL as such, but there's other kind of scripting that is available on iOS XR. I don't have the complete details, but about the scripting part and the partner link for iOS XR, we will post it on the event page.
Okay. I guess we are run out of the time, and if you have more additional questions or we didn't get a chance to answer your questions, head over to Cisco support community on Google Plus and Cisco support community on cisco.com. We have listed the URLs here. Visit those URLs to find the community on Google Plus and also community on cisco.com. And there you can find answers to many of your questions about Cisco products and services. Thank you so much to our expert Vivek Ruhel for sharing his expertise with us today. It is a very informative session. And I would like to invite you to our upcoming Hangout on Air, which is going to be taking place on October 3rd at 10 a.m. Pacific time. The topic for that Hangout is Building Widget with Cisco On-Demand APIs. Make sure you sign up the upcoming Hangouts today at Cisco Supports Community on Google+. And we encourage you to invite your colleagues and friends to our community and to our future events. Again, thank you for joining our Google Hangout. You have a great day or great afternoon or great evening. Thank you. See you next time.